Okay, let me start with the first question. How risky is inhalation of asbestos and why is obviously asbestos is the very toxic element and it is a carcinogen. So clearly inhalation of asbestos has large health risk. But as far as use of jaggery is concerned, I am not familiar with any studies done to see whether consumption of jaggery or in what proportion consumption of jaggery counters this risk. So I mean, as of I am concerned, I do not know any studies conducted in that way. The second question is that what is the level of air pollution during COVID lockdown? I think several people asked these questions. I showed this graph. In fact, in all India scale, if you really see, what you notice is that there are always these ups and downs. And keep in mind, obviously, that there are changes in meteorology and stuff like that. So yes, there are varying proportion of improvement, as I was showing. Like in Delhi, for example, or especially in the places where pollution level is strongly controlled by local emissions, maximum benefit is clearly observed in those places. However, if you go to the rural areas or even in the background places like in eastern UP or central UP, what we found is that there is not much benefit from this lockdown. And the reason is simply because, those places are mostly affected by long range transport or transport from the nearby urban areas. So again, it's what is very important to keep in mind that there is some feedback going on. So if you have too much particles or too much pollution in the atmosphere, what it usually does is that it cuts down the solar radiation and it stabilizes the lower part of the atmosphere. In other words, if you have too much pollution sustaining for quite long time, it creates actually a very stable atmosphere, and that itself again increases the stagnation of the atmosphere. So this kind of feedback is very important in rural areas or in the background sites. As soon as you try to reduce the local emissions, slowly it will also affect the feedback. And as I mentioned, that we need to really look into the data in tandem with the meteorological data, which we started actually. But yes, mostly from the reported number, even the CPCB has published a note on COVID lockdown impact. And from place to place, the pollution level has improved by 20 to 30, 40, 50%. But my point here is actually, if you really see that many places, again, it's coming back to the pre-lockdown level, and that's what actually is very interesting to study. Then there are some questions like, what is the reason for rise in pollution levels in the peninsular India compared to IGP? Why anomalies in emissions? Yeah, so anomalies in emission and concentration. So when it comes to concentration, it's not just a function straight away of emission, but also the contribution of the upwind sides plus meteorology, and that's why we see actually this larger anomaly for the concentration compared to emission. So the emission plot which I showed, that is mainly the local emissions. It's not the emissions in the nearby region. And the first question, like, what is the reason for rise in pollution levels? So what we found is actually that especially the places, especially the focus has always been in the Gangetic Plain and or the Delhi NCR, but it has never been actually in the peninsular India and all. And those are the places where the emissions are increasing at rampant rate without any consequence. In fact, if you look into the power plants in eastern India or peninsular India, there is no sort of control guidelines on their emission norms. And I think these are very important things. In fact, this is the reason why we are finding that the rate of increase in pollution in the smaller cities is much more than the larger cities, because the focus has always been on the larger cities. Then there are some question. Okay, so someone has asked what is GRAP. So this is the Graded Response Action Plan implemented in Delhi to curb pollution. There is a question called why this rise in 2003. So the Delhi, again, those who are not familiar can go back to PCB. There are several documents actually what happened is that in Delhi, CNG was implemented in 2002 to curb air pollutions, and that time actually the decision was made based on the PM10 measurements. In general, PM10 and PM2.5 go hand in hand, and typically, what we found in Delhi is that 80% of PM10 is actually PM2.5. So what we found also that, after CNG implementation, PM2.5 has also gone down. I mean, since there was no ground-based measurement, so there was no basically evidence that PM2.5 is actually going down after CNG implementation. That's what I wanted to make the point. I did not talk about ozone, but there was a question on trend of tropospheric ozone concentration in India. Unfortunately, very few places we are measuring ozone, and in fact, ozone actually deserves a complete different talk because it's a very complex pollutant. But I can only, and in fact, if you talk about trends, very few limited data available. And from that data, what researchers have found that ozone level is increasing. In fact, we have measurements of during lockdown, for example, there is considerably high ozone. Now, why ozone is so special? Simply because ozone is a secondary pollutant. And if we have learned anything from the air pollution studies done in places like Los Angeles, London, and various other places in Western world, everywhere where the particulate matter problem is resolved, now those cities, those countries are dealing with ozone problem. And I think that is why India should not forget about ozone, although currently in India, ozone is not a very big problem, but in future, if we don't do anything, it may emerge as again, a very important problem. But as I said, we do not have very robust measurements or adequate measurements of ozone. Now for ozone, if you try satellite or if you try other methods like models, the challenge here is that it's extremely difficult to simulate ozone using models. And again, there is a whole, and that's actually an active area of research. Then there is some question about the seasonal changes in PM2.5, which I showed. Yes, we understand now that why PM2.5 starts increasing from November onwards. And this is mainly what I explained, actually, the meteorological effect. So November onwards, and as soon as your temperature goes down, the atmosphere becomes very stable. You do not have any wind. So what is happening is that, whatever you are emitting is actually just stagnating close to the surface. It's not dispersing. It's not transported. And that is why you can see this massive change in the concentration level. So meteorology or weather pattern, that's why is very, very important. And from policy perspective, what I believe here is that because of this, right now, somebody asked about GRAP, that is the Graded Response Action Plan. In my opinion, right now, the way GRAP works is that once we are in very extreme condition, then we sort of switch off some sources. In my opinion, what we should do is that now we are doing air quality forecasting with very reasonable accuracy. We should link GRAP, in my opinion, to the air quality forecasting. Or in other words, we should take action before air quality plunges into the extreme level. Once air quality moves into extreme level, no matter how many sources you switch off, air will not be clean unless meteorology favors. And that's what our experience is, that even if you switch off power plants, if you stop construction and everything, still it takes at least 3 to 4 days before it again comes back to at least high or extreme, very high level. Somebody talked about transportation, resuspend, so I did not talk much about other sources, but if you really see, I think this is an interesting question. Some other attendees also asked this question. If you really see in India, you will find mostly there are 7-8 sources. What are these sources? So you have household emissions, you have power plants, you have vehicles, you have industries, you have open burning, you have brick kilns, you have diesel generator sets, and you have dust. And when you say dust, there are 3 types of dust. One is construction dust, one is the dust which is transported from the arid region, or even, from the, locally also it's raised from agricultural fields and others. And the third type of dust is the resuspended dust. So all these 8 sources are very important. Unfortunately, when it comes to emission estimates, we have very poor estimates of resuspended dust. And also we have very poor estimates of some of the unorganized sectors. And I think this is, again, it's a very critical issue, because when you talk about vehicles, resuspended dust is an important issue to keep in mind. And immediately what is required actually is a national inventory for resuspended dust. Then there are some other questions like, what are the optical techniques currently used for air pollution monitoring? Yeah, so the way air pollution monitoring is conducted right now is that the best technique is still the gravimetry technique, the old school technique, where you collect particles on a filter, go back to lab, do the analysis. So that's the super accurate. However, you cannot do that continuously. That's why this continuous instruments were developed. Now, all the continuous monitoring systems, they use a laser, or the optical techniques. Basically, what they do is actually they use a laser, and then using that laser, they count the number of particles deposited on a reference filter, and from the number of particles, you convert it to the mass, either it for PM 2.5 or PM 10. Now, again, there is some sort of calibration required when you try to convert from number to mass. And again, what has been observed that the conversion factor, especially the density, what is used when you calculate mass from number, does not remain same. From place to place, density varies depending on the mixing state, depending on the hygroscopicity of the particles, and so on and so forth. However, we do not have this information. Yet, continuous monitoring gives continuous data, which is very important for the management perspective. Now, if you ask me in terms of policy, what I will say is that even if your measurement has 5 to 10% error, it should be good enough to form policy, because when you are at 200 with 10% error, that means, a measurement of 200 microgram per meter cube could be, let's say, 180 or 220. And even with that kind of, error margin, you can always make this decision. And if you see, there's different AQI levels, reducing 200 to 190 doesn't make sense. So my point here is that when you talk about measurement uncertainty, yes, that's a very important point, but at the same time, we have to also make decisions. And that balance is very much required, and that's what I think any methodology will do. As I showed that, like the satellite-based techniques also have some uncertainty which we defined. And now I must mention that some people are asking about low-cost sensors and stuff like that. Yes, low-cost sensors are also emerging as a very interesting tool to fill the data gap. A lot of efforts are there now to improve their performance, improve their durability, because we are in a stage in India where now low-cost sensors are just appearing in the market. So we need to understand which low-cost sensor works good or bad, how their performance varies with the environmental conditions. And I am sure, in fact, when I started my work with satellite data way back in 2010-11, we are at these positions. That time we never knew that we'll come all the way to here, when actually satellite data will be used by pollution control boards. But we are now here where actually satellite data are being used by the policymakers. So I'm sure in coming years, low-cost sensors will also reach to that level. In fact, National Physical Laboratory has been tasked to develop a calibration facility for all kinds of sensors in India. And once it starts operating, and which should be in couple of years, then any kind of sensor, not just low-cost sensors, but even traditional continuous optical-based sensors can also be calibrated there, and this error can be better quantified. Then There are some other questions. Oh, there is another interesting questions about the standard for indoor air quality. I think this is very important issue. Unfortunately, in India, there is no standard for indoor air quality. However, we recently performed actually from SARCA a study in collaboration with Society for Indoor Environment. What we found here is that indoor air equally is bad, and indoor air means typically I'm talking about urban indoor conditions where people are not burning solid fuel using chullas. Even then, the indoor air is equally bad as of outdoor air. However, when it comes to air pollution, people still think that if you are indoor, condition is really good. So clearly, the first step would be to develop some sort of database for indoor air. In fact, many cohort studies, including one which we are currently doing now we are not doing basically, but we have been doing for the last couple of years, are measuring indoor air quality using different sensors. I think we need to first establish a database for indoor air quality for different indoor microenvironment, like office, cinema halls, urban houses, rural houses, and stuff like that. But I think this indoor air quality issue has to be undertaken, and India should develop a proper standard for indoor air quality. There is a question also on the exposure. So I think this exposure is again very interesting aspect, because ultimately it's the exposure which is used for any health risk studies. Now, if you think from exposure perspective, then many sources become even more important. For example, if you and that's where actually this concept of intake fraction is very valuable. What is intake? I'm not sure whether people are familiar with intake fraction, but intake fraction is simply amount of exposure to any pollutant per unit emission. And if you think about intake fraction and compare power plant and vehicles, you will find that vehicles are much more important, because what happens is that yes, one power plant emits much more, but that pollution is sort of dispersed. But vehicular emission, the vehicular emission actually impacts more people, because the people are actually very close to the vehicle. So the exposure level is very, very high to vehicular emission. Exposure level is very high to open burning. Exposure level is very high to household emissions, because people are just next to the emission sources. So again, when you think in terms of exposure, I think, again, from policy work is required to dish out in terms of intake fraction, which sources actually to give more priority. Then there are some other questions on, somebody asked about a question like peninsular India. So I just want to clarify that the graph what I showed is actually not the overall pollution level, but the change. And in fact, I already explained that what I found in the last 2 decades, the central or peninsular India has shown larger rate of increase in the pollution level than Delhi, NCR, and other places because of multiple reasons. Then there are some questions as per our should be ground and as far as air quality management is concerned, what I was telling, rather trying to explain, is that we need to find out solutions which are cost effective and which are easy to implement. And that is why, I was telling like going for mitigating household emission makes sense. But other than household emissions, then if you think about all other sources, obviously what is easier to handle is open burning. And in fact, policy has been implemented. There is massive effort undergoing, to really curb open burning across India. Hopefully, in few years, open burning will come down. And then obviously, if you think about sources like industry, sources like power plant, sources like vehicles, what is important, obviously, is that in Delhi now we are switching to BS6, which is expected to reduce tailpipe emission by at least 60 to 80%. However, we should keep in mind that not all vehicles will run on BS6, but slowly over the years, what will happen? Old vehicles will be replaced by newer vehicles, and eventually, let's say in the next 8 to 10 years, bulk of the vehicles will run on BS6. So tailpipe emission will come down, but we should not forget that just controlling tailpipe emission is not enough. We need to really work on the resuspended dust due to the vehicular traffic. Again, for all these important sources like power plant, vehicles, and industry, what is very important is actually to maintain, or rather, to monitor progress. So policy is there, but there is report of flouting the norms. For example, the industries are told to keep their emissions within this, but where is that data? I mean, unfortunately, what is happening is that most of the industries are supposed to measure the emissions, but this data also lie with the industry itself. And this data is not open to public. And that is why we really do not know whether data is being manipulated or whatever is going on. So I think it's very, very important to develop a framework or mechanism to really see whether the industries, whether the big cleans or this kind of the power plants are really implementing the measures which are mandated by NGT and Supreme Courts. Then there are many other. Yeah, so there is another question on electric vehicle. I think this is again an interesting question and policy dilemma. So yes, I think people have already started talking about EVs, which will definitely reduce substantially the tailpipe emission and stuff like that. But we need to also evolve, or rather, we need to really do research on two aspects before we really recommend EVs to EVs for implementation. The number one is the major challenge with EV is obviously the power requirement. If it turns out that and whatever extra power, imagine 30% of Delhi's vehicle is transferred to EVs. We need to find out from where this extra power will come. And if it comes to a situation that we need to burn more coal in some power plant in rural areas to generate that extra power, in my opinion, it's nearly not solving the problem. What is only happening is that we are reducing pollution in Delhi to pollute some other place. And the second important point, which many of our colleagues in Sarkar are working on, that is how we handle the batteries. And again, as of now, a lot of discussion is going on. So EV is an interesting premise for which we need to really do research on several aspects, especially on these two issues. Then there are some questions. Somebody asked, like, how can we be part of this Maya mission? Okay, so no, this satellite mission which is coming up, for example, this is a NASA mission. However, the NASA's policy is that as soon as the satellite will be launched in early 22, like in 2 years' time, in few months, all the data will be made available to everyone. So as soon as the satellite will be launched, we are anyway now working to develop the algorithm, testing it and all. In fact, I just must mention that part of, for this mission, we are going to put 4 PM2.5 speciation monitoring site inside Delhi NCR to constrain the satellite algorithm. And once the satellite will be launched, and then the data will be made available to anyone who can then look into data, try to make sense out of it, do their own studies and all. In terms of research, yes, this is an interesting research, that how do you sort of extract PM2.5 compositions using models, using different kinds of measurements. So that we can discuss offline. Then there are also questions like, so there's a question like contribution of household is highest. We are not aware of that. We are more focusing on implementing rules. Yeah, so what I said is that it's not like we are not aware of that, but government has been trying to, address multiple sources at a time. There are different schemes. there is a scheme for tackling household emissions. There are now schemes coming to tackle vehicular emission, industry, and so on and so forth. What is important here is that active public participations. Now, why I am mentioning about active participation is that we must keep in mind that there is a limited resource available to the pollution control boards. We cannot expect just the pollution control board people to solve this problem for us unless the general public helps them. Obviously, their job is to keep the air clean, but you need to also think realistically that there are too few people in pollution control board. And in fact, now what is happening is that in the pollution control boards, it's not the job of the pollution control board people to roam around the cities and try to catch people who are not adhering to the norms and stuff like that. I think all these policies which are implemented, it's important for everyone to be part of it and contribute to this cause. Then there are some other questions in terms of some data like tropomy. I think, I did not mention. So we also looked into data of other pollutants like NO2, SO2, ozone, VOCs, and many other pollutants. In fact, the largest drop has been seen in NO2. Especially the question was about NO2, and yes, because NO2 is a classic signature of vehicular emissions, and some NO2 is actually emitted by the power plants. So most of the places we have seen the largest decrease in NO2 and nitrate aerosols also. So this is actually indicating that during lockdown, clearly the maximum benefit wherever is observed is coming from the massive reduction in vehicular emissions especially. Then there is another question is that what is your take on the transport of polluted aerosols from a highly polluted area to meteorological factor, to less polluted areas driven through meteorological factors contributing? So I think this, I already mentioned that this is very important, that when we talk about air pollution action plan, we often forgot that air pollution in a place is affected by long range transport. Now, I will take this classic example of Lucknow and Kanpur. If people are familiar, Lucknow is downwind of Kanpur. And in between Kanpur and Lucknow, we have this Unnao, which is basically a rural region. Now, imagine, so now the point here is that, Lucknow, obviously, whatever you do in Lucknow, it will impact Lucknow's air. But Lucknow's air is also affected by the air transported from Kanpur. So imagine a situation when Lucknow has done a lot to reduce its emissions. However, if Kanpur fails to do so, that impact will be visible in Lucknow. And that is again a very important point in the entire National Clean Air Program, that the National Clean Air Program has mandated every city to come up with its action plan. And in fact, most of the cities, non-attainment cities rather, has come up with their action plan. But most of these action plan lack this sort of regional cooperation. That means every action plan is just focusing on what that particular city will do. And this is where the danger lies, is that unless we establish a proper connection or proper connectivity between the action plans of the cities lying in a airshed, never an action plan will succeed. And that is why actually any air quality management plan has to be focused on airshed, not just particular city or particular village. Now we are also working, and several other groups are working, like NIRI and others, to look into these different airsheds and trying to understand what is first of all the airshed. Even if we ask actually in India how many airsheds are there, there is no clear-cut answer. In fact, this is again in a very important area of research. We must identify the major airsets for the country and major airsets for a particular region. And we need to really move from city-centric approach to the airset-centric approach. Otherwise, no plan will succeed. Then there are questions like, yeah, I mean, there are questions like technology and stuff like that. So I see some kind of questions related to technological interventions. So yes, technological intervention is important. For example, now if you talk about Los Angeles or Chicago or New York or London, it's not like no vehicles is flying there. But what they did is they were successful in reducing tailpipe emissions significantly. So there are millions of vehicles flying in Los Angeles, yet the Los Angeles air quality in terms of PM 2.5, you see it's still in that 12 to 15 microgram per meter cube range. So for certain sectors, technological intervention is very much required. But if you ask me personally about technologies like this outdoor air purifier, I am not very fond of this. The simple reason is that at this point, most of the purifiers are actually require a very large amount of electricity. And again, this raises these important questions that even if these air purifiers are very efficient in cleaning air, but if it needs massive electricity, that electricity has to come from somewhere. And somewhere means right now we are still relying on, for power, we are still relying on power plants, which again, burn coal. So unless we develop technologies, especially for air purifiers and stuff like that, which can run on renewable energy, I don't think it's a feasible solution. Then there are many questions, in fact, coming. So how much time we have, Diksha?
So, Professor,
maybe 5 more minutes. We are 7:15 now, so maybe like last 2 questions you can take.
Okay, so there are many questions, in fact, which are coming in terms of like. Okay, so many questions are coming regarding data. I'm not reading specific questions, but anyone needs any kind of data. Many questions are asking about, from where we can get this data, that data. So you can just email me personally. I'll be very happy to help you. So there are plenty of satellite data, plenty of data available from multiple things. Even model outputs are now made available to public for use. So if the data is available, I can guide you. So that will answer a lot of questions who are asking about data. Then there are some questions regarding reforestation. I mean, strategy like reforestation and all. Yes, obviously, greening or increasing the vegetation cover is very important to curtail pollution from various aspects of it. However, most of the city action plan, what I have seen under NCAP, has very vague mention of that. Vague mention means, every city action plan has said that, we'll put plantation, stuff like that. And you need to understand that, if you take any city, for example, and when we commit that, okay, we'll put, let's say, X million trees, or if not million, let's say a few thousand trees, we need to find out where is the space to, go for such kind of tree plantation inside the city, and then try to see actually if you put, or if you rather, make one part of the city where it is possible green, how that will impact. So that kind of study, or at least in a preliminary survey, is required. It's not just enough to say that yes, we'll plant, let's say, 1,000 trees. So those kind of detailed plan is actually missing, in most of the action plans. And I think last, so someone is asking, like, there is a lot of shout about agricultural activity, burning of agricultural waste and all. So I just want to point out here, there is plenty of evidence that the first major pollution episode in Delhi is impacted. But I want to very strongly emphasize on one fact is that this is not the time to demonize the farmers. In fact, we must realize that the farmers, they do not have any other alternative at this moment. So unless we provide that alternative to farmers, this problem will remain. Now, several other alternatives are being tried. Just to give, those who are asking questions about agricultural burning and stuff like that, in that particular agricultural season in October, almost 10 million tons of agricultural waste is generated in Punjab. And this is massive. And unless, the question is that how do you manage such agricultural waste? We need to really, focus or rather develop a system where actually you can handle this huge amount of waste. And the time window available to the farmer is very short. It's just 14 to 20 days. So we really need to give farmers an alternative. And in fact, when you talk to the farmers, and many of my collaborators, they work at the ground level. Farmers also know that, when they burn this agricultural waste, in fact, they're asking these simple, innocent questions that ये हवा और ये pollution दिल्ली जाने से पहले हमारे लांग से होते हुए जाते हैं. So they know that, when they're burning, it generates pollution and it's impacting their family first before it reaches Delhi and all. So what we need to do is really work hand in hand with them, provide them technological solution, provide them other kind of solutions. And one such long-term solution which is being discussed now in the policy forum is crop diversifications. Because this problem started when Punjab actually started growing rice. So, and probably the last question, not other day. Okay, so somebody, okay, so I think couple of questions regarding how PM 2.5 is measured from satellites. So I briefly explained, you please read those papers, and if still you have some problem, you can just email me or you can call me, because it's I need to explain several things, how actually, but very quickly, if I say that satellites, they do not measure PM 2.5 directly, it measures something else, and then there is a whole different physics involved before you actually come to PM 2.5. So I will be very happy to answer directly. Yeah, so still questions are coming. So Diksha,
I think they can email you later on, because that's what
yes,
we are continuously doing. We will type your email ID here, or Sagnik Dey IIT Delhi is available on web. So please browse his name and go to his homepage. There is even a lot more information about his research and like the research publication and everything. So strongly encouraging all the participants to visit his homepage and then contact him. Thank you so much, Professor Dey, for sharing such a fantastic knowledge, deep insight, and a broader perspective. It is definitely one of the most critical topic as well for the country. And everyone is thinking like the day when we have like a really clean air to breathe. And obviously there is a short-term phase lockdown. And as you mentioned, there are several reasons we don't know. So hopefully, I think this is a topic of national importance, as we discussed before, and would keep attracting a lot of curiosity and excitement from a researcher all over. With that, I thank everyone for their participation in this talk. We really had a very good attendance. Nearly 200 people attended the talk, and several questions, 86 so far coming up. So please follow up with Professor Dey if you continue your curiosity and inquisitiveness. He'll be more than happy. And thank you once again. Stay safe, stay indoor. Thank you, Professor Dey, once again for joining and sharing your time.
Yeah, thank you, Diksha, and thank you all for listening and asking such interesting questions. And students, if you're interested, please apply to open positions for IIT Delhi and from research group. Thank you all.